This is from the number theory revision questions, so look at 3a. Okay, so we've got to prove that this number, base p, is composite, so not prime. It has factors for all p that are greater than or equal to 14. Okay, now we're going to remember that d is the equivalent, so I'm going to, d is the equivalent of 13, okay, and c is the equivalent of 12, okay, and now we're working base p, so this is in the place values, this is p to the 0, p to the 1, p squared, p cubed, p to the 4, p to the 5. So actually this number could be written as 13 p to the 5 plus 12 p squared plus 1. So we have to show that this can be factorised when p is greater than or equal to 14. And it can be factorised into non-trivial factors, that means not just 0 or 1. Okay, I'm going to call this f of p, okay, and I'm going to use the factor theorem to test out if p is negative 1, whether we get 0 and therefore we get a factor. So that'll give us negative 13 plus 12 plus 1, which is indeed 0, which then tells us that p plus 1 is a factor of f of p. Okay, so now we can do a division to find out what the other factor is. So I'm going to use the grid method. So I've got, because it uses less space. So I'm dividing p plus 1 into 13p to the 5 plus 12p squared plus 1. Okay, so I'm going to start off with 13p to the 5. I need to multiply p by 13p to the 4. And if I then multiply these, I've got 13p to the 4. Now I don't want that. Okay, I want 0p to the 4. So I'm going to subtract 13p to the 4. Then we think how many p's go into that? Minus 13p cubed. Multiply these out. Minus 13p cubed. I don't want any p cubed, so I need to add 13p cubed now. P times positive 13p squared will give me the 13p cubed. Now I multiply by 1. Okay, I do want some p squareds, but I only want 12 of them. So I'm going to take away a p squared. So I'll need to multiply p by p to get to give me, by negative p to give me negative p squared. And if I multiply by 1, I get negative p. However, I don't want any p to the 1, so I'm going to add p. Okay, and I do p times 1, gives me that, and 1 times 1 gives me the plus 1, which is fine. That's where we finish. So that tells me that f of p is p plus 1 times by this awful quartic, 3p to the 4 minus 13p cubed plus 13p squared minus p plus 1. So we have to just now show, so we've showed it factorizes, so it looks like it'll be composite. It's only definitely composite if neither of these is 0 or 1. Okay, so if p is greater than or equal to 14, then p plus 1 is greater than or equal to 15, so that's not trivial. And then if we look at this quartic, 13p to the 4 minus 13p cubed plus 13p squared minus p plus 1. I'm going to have a look at that on my calculator in graph mode. Okay, so I've got 13p to the x to the 4 minus 13x squared cubed plus 13x squared, and then I just want to have minus, oops, I've got a bit of a mess over here, so I should have minus x plus 1, that's better. Okay, and my view window, I want my x's to go from 14 upwards. So my x minimum is going to be 14. I have a feeling that I'm going to need massive numbers. Let's go up to 50. There we go. And my y minimum, I'll just do minus 1 because I want to make sure it doesn't go past 0. And let's do up to 100. Okay. Wow, I can't see any of it. So view, not view window, zoom. Let's do auto zoom. And hopefully it'll find the graph somewhere. There we go. Right, so I'm going to use trace, and you can see it's always increasing. I'm going to use trace, and I'm going to type in 14 for my x. Okay, So that means that from the graph it's always increasing, and that this thing is always going to be greater than or equal to 466,271. So that's definitely non-trivial when p is greater than or equal to 14. Okay. So conclusion: non-trivial factors can be found. So D00C01 base P is composite for all P greater than or equal to 14.